Hello everyone, here is Fix Team. I'm Anthony. I'm very happy to meet you here. Today we are showing you the online class. Okay, come on to the class. Okay everyone, today is the class 8 and today we will talking about the principle of the baseband and the signal theory. Today also have 3 parts on this class. First is the principle, and the second is how to test and how to repair. And the number 3 is the case showing to you guys. Now we're talking about the signal part, and in the iPhone the signal part is controlled by the baseband CPU. And the baseband want to working normally, he have the power working condition, and the power is from the baseband power IC. And the baseband control the RF progressor to control the phone, the signal transmit and receiving. So in this class, we will talking about the baseband power IC and the baseband CPU and the RF progressor and the signal receiving and transmitting circuit to one part to teach you guys. Before our learning this class, we need to know that the signal circuit the working through. First is the baseband power IC working. After the baseband power IC working, and he will give the power to the baseband CPU. And the CPU will control the RF progressor working. After that, the signal receiving circuit will work, and the signal transmitting circuit also will work. After the signal receiving and transmitting all is working, and the phone will go to the standby. Now we're talking about the baseband power IC, the circuit first. And also first of all, we also know that the main function of the baseband power IC. And his main function is provide the power and the signal, clock signal for the mobile phone signal circuit. And the baseband power IC want to working normally, he also need 2 working conditions. One is power and the second is signal. Okay, now we see the power line first. And as you can see, the red line is the power line and the blue line is the signal line. Now we see the pin 5, the upper. The pin 5, this line first. And this pin 5 is the power to the baseband power IC. He connect the PP VCC min this line. And you can see the 18.6 and 14.4 and 14 and 18.9. These 4 line. You can see the position is lower the pin 5. And this 4 line also the power to the baseband power IC. And where is this 4 line the power? From where? He also from the power IC itself. Now we see the baseband power IC, the right side. When the baseband power IC the first time working, he will send out the 5 power. You can see in the right side of it is SMP, S1 and S2 and S3 and S4 and S5. These 5 power is the first time the baseband power IC working send out it. These 5 lines power all is sent to the baseband CPU. And after that, the baseband power IC, the second time to output the power is a lot of the LDO. And you can see that those LDO is, the price is lower than that 5 first time output power. Actually, those LDO power is exchanged from the S2, S3, S4, S5, these 4 line exchange it. So the S2, S3, S4, S5, those 4 line is output from the baseband power IC, but it also working for the baseband power IC. Okay, now we see the 14.3 and 13.7, these 2 pin. And as you can see, the 14.3, this pin is the U2000, the main power IC, the PMU, the reset signal to the baseband power IC. And the 13.3, this pin, the 9 is the U2000 PMU to the baseband power IC, the common voltage detect signal 9. And continue go down, you can see the 15.8, this pin. This is the CPU to baseband power IC, the in power signal 9. And then continue go down, you can see the CPU, the G3, this pin. This is the CPU to the baseband, the reset signal. This signal is working for the baseband CPU and the baseband power IC in the same time. And this line is very special. This line also is the baseband CPU to the baseband power IC, the power holding signal. Okay, this signal we will talking about in the detail in the coming class. And continue go down, you can see that the 25 and 13.1, these two pin, the 9 is the baseband CPU to the baseband power IC, the SPMI control bus. And continue go down, you can see the 13.2, this line. This line is SIM remove signal 9. This line is working for the remove the SIM information. This line, the function only is working for the when we remove the SIM card, and it will delay and clean the last SIM card the information. And the baseband power IC want to working normally, he also have a clock crystal. It seems like the PMU. He also need a clock signal to him to let him working normally. And as you can see, the left side, the end of the IC is the baseband power IC clock crystal. And continue go down, you can see that the 13.4 and 14 these two 9. This is the signal line about the baseband power IC, the internal clock shock signal. And you need to pay attention in this capacitor. He have a capacitor. If this capacitor is missing or have some problem, it will cause the baseband power IC clock crystal not working normally, so that the mobile phone have not the 4G signal, and the signal is also abnormal. And continue go down, you can see the 17.4 and 17.9, 17.3 and 16, this 4.9. This 4.9 all is the baseband power IC, the interrupt reference signal. And if this small thing, the small component missing or have some problem, also will cause the baseband power IC working abnormal. And in the before, we have been talking about the main function of the baseband power IC. He not only provide the power, he also send the clock signal. So now we see the baseband power IC, the red and downside, the blue line. And now we see the first line. This is the 16.3, this line. This line is PMC RESOUT. This line is the baseband power IC to the baseband CPU, the reset signal 9. And continue, you can see the 15.6, this line. This line is XOUTDOEN. This line is the baseband power IC to the baseband CPU, the clock in power signal. And maybe you don't know that the XO is mean that the baseband power IC clock crystal. And continue, you can see the 14.5 and 13.5, these two lines. This two line is the baseband power IC to the baseband CPU, the clock signal. And you can see the 17.2, this pin. This pin is the baseband power IC to the baseband CPU, the clock sleep signal. And you can see the pin 4. This pin is the baseband power IC to the baseband CPU, the voltage regulation reference signal. And continue go down, you can see the 15, this pin. This is the NFC to the baseband power IC, the clock recurrence signal. And 17.7, this pin is the baseband power IC output the clock signal to the NFC. And this clock signal is 19.2 MHz. And 16.6, this pin is the baseband power IC to the RF progressor, the clock signal. This signal also is 19.2 MHz. And this is the baseband power IC circuit. And now we're talking about the baseband CPU circuit. And as you know that the main function of the baseband CPU is the responsibility for the progressor of the signal circuit. And his working condition also have two. One is power and the second is signal. And his power is from the baseband power IC. The baseband power IC sending the 16 lines power to the baseband CPU. And now we see the signal part. And in the before, we have been talking about the data signal from the baseband power IC to the baseband CPU. So now we focus on the AA16, this pin. This pin is in the middle of this picture. And as you can see that this is the power holding signal. And when the phone is power on that, and PMU and the CPU will control the baseband power IC working and sending the S1, S2, S3, S4, and S5 this 5 power to the baseband CPU. When the baseband CPU get this 5 power, and the baseband CPU will checking itself. After he finished, he checking itself, all is finished, all is perfect, and then he will send the power holding signal to the baseband power IC to let the baseband power IC to continue to sending the other power to it. Okay, this is the power holding signal. And continue go down. You can see the U10, W10, AA11, Y11, AA13, Y13, these 6 lines, all is the CPU to the baseband CPU, the PCIe control bus. And continue go down, you can see the J3 this pin. This is the CPU to the baseband CPU, the SWD debugging signal. And continue go down, you can see the AA22, Y23, W21, and Y22. This 4 line is CPU to baseband CPU, the I2S song communication signal. Why here have the song communication signal? The reason is when we are calling, the baseband CPU will exchange the radio signal into the digital signal, send it to the CPU. And the CPU let this digital signal to the audio IC, and the audio IC will handle it and send it to the speaker, and after that we can hear the songs. And if this phone line have some problem with case when we are calling and the other partner cannot hear the voice. And continue go down, we can see the W3 this pin. This is CPU to the baseband CPU, the PCIe wake up signal. And the T5 this pin is the CPU to the baseband CPU, the reset detect signal. And the A2, R3, and U5, this V9 all is the CPU to the baseband CPU, the data signal. And continue go down, we see the K20 this line. This line is the baseband CPU to CPU, the clock recurrent signal. And the U6 this pin. This pin is the CPU to the baseband CPU, the reset signal. And see the Y2 this pin. This pin is the baseband CPU to the main CPU, the PCIe hosting wake up signal. After the baseband CPU, these two working condition all is enough, and then the baseband CPU will start to work, and the baseband CPU will use the RFFE control bus to check the load component of the signal circuit. And about the RFFE, this part we will talk in the coming class. And you can see the down of the RFFE, those lines from the A4 to the F222, this line all is the data signal line. The baseband CPU use those signal line to control the receiving and transmitting of the RF progressor. And continue go down, we see the A21 and B21. In the signal, the transmitting and receiving have a lot of the power amplifier, PA. Here we will talking a small note. Every mobile the position to the base station, the distance is different. So the frequency of the power amplifier is different. So the baseband CPU need to control the power amplifier power IC to let the power amplifier be bigger, let the signal be big, and let the communication of the signal be stable. So this A21 and B21, these two lines address the signal. And we see the U14 and W14. These two lines is the baseband CPU to the USB control IC, the data signal. And go down, you see that the J23 and J102, these two lines is connect to the baseband EEPROM. And the baseband EEPROM have a lot of the baseband verified information. If the baseband EEPROM have some problem, the phone will not have baseband and cannot repair. And go down, you can see those lines is the SIM circuit. And the SIM card is same, so the SIM card, the circuit also is same. And now you can see the red port in the SIM card holder. This port is GND port. And the number 1 pin is the power line. This line is 1.8 voltage. And the pin 2 is the SIM signal line, the reset signal. And the pin 3 is the clock signal. And the pin 7 is the data signal. And you can see the pin 6. This pin in before the iPhone 5S, this pin is useless. This pin 6 is SIM internal programming pin. But from the iPhone 6, this pin 6 is connected to the NFC. And the pin 8 is the SIM card, the box wrap switches. And this is the SIM circuit. And continue go down, we see the K3 and B2. This 2 pin is the baseband test pin. Is useless because these 2 test pins only for the factory. And continue go down, we see the V22, E1, T3, U12, U8, A810. This 69 is the baseband CPU reference signal. And in this line, you also can see the small component. If this resistor have some problem, okay, baseband CPU working abnormal. So if those components have some problem, we cannot missing it. We only can install back the same resistor. Okay, this is all of the baseband CPU circuit theory. And now we're meaning talking about the baseband RFFE control circuit. From iPhone 6, the Apple is upgrade the signal part. The Apple company, in order to save the battery power, after upgrade this signal part, it lets the baseband CPU use the baseband RFFE control circuit control line to control the signal component. Why he can save the battery power? Because before the iPhone 5S, the iPhone have not the RFFE control lines, and the PA, like the power amplifier like this, he always working. But now after from the iPhone 6, the baseband can use the RFFE control lines to let those signal components to let it work or standby. So it can save the battery power. And as you can see, the baseband CPU use the RFFE1, this data line, to control the RF progressor in the B23 and 24, these 2 pins. And continue go down, you can see the E13 and A23. The baseband CPU use the RFFE2 signal line to control the middle band power amplifier IC and the high band power amplifier IC and the low band amplifier IC and 2G power amplifier and low band antenna switch and high band antenna switch. And go down, you can see the baseband CPU use the RFFE3, this signal line, to control the RF antenna switch. And go down, you can see the D22 and D23. The baseband CPU use the REFF4 signal line to control the RF power amplifier power IC. And go down, you can see the E22 and F20. The baseband CPU use the RFFE5, this signal line, to control the buffer IC and J4600, the type block connector, and the antenna switch and up antenna switch. And those is the baseband RFFE control circuit. And the baseband CPU use the RFFE control lines to check the quality of signal component. And one of those signal components have some problem and the baseband CPU will not work. And also will case the signal sometimes is having, sometimes is have not. Now we're going to talking about the RF progressor circuit. And the main function of the RF progressor is responsible for the receiving and transmitting signal. And the RF progressor, when to working normally, he also have 2 working conditions. One is power and the second is signal. And the power is from the baseband power IC. He have 2 nice power supply. This 29 power line is the baseband power IC, the 100 pin and the 12 and the 2, this 29. And as you can see, in the pin 100, it have two resistors. These two resistors is so important. If these two resistors is loose, will cause the RF progressor working abnormal and cause no signal. And then you see the 14.6 this pin of the RF progressor, and this line is the baseband power IC to the RF progressor, the clock signal 9. And the width all is the baseband CPU to the RF progressor, the control signal 9. And as you can see, the 16.2 and 14.7, this 2.9, all is the RFF19, the baseband CPU to the RF progressor. We have been talking about it. Okay, this is progressor circuit. And now we're talking about the signal receiving and transmitting circuit. And this part, the circuit is so special and difficult. So we divide this circuit into the 2G and 3G and 4G circuits. And in this picture, you have been see that here have a lot of the component, have power amplifier, have antenna switch, have the filter, and also have the RF progressor. And in the before, we have been talking about those signal component all is controlled by the baseband CPU. The baseband CPU use the RFFE control 9 to control those signal component. When preparing the signal part, first of all, you need to understand the coverage of the operators in your country or regions. Understand their signal frequency band, and then organize this information into a table, which will helping you repair the signal part. The signal repair is complex, and if you want to learn more, you can come to China to join in our offline full training. We will expand it more and more detail. Okay, now we're going to talking about the baseband power IC, how to test and repair. The first, we need to test the baseband power IC or the output 9, the resistance and voltage. And for example, the iPhone 6s, we have been making all the information of the baseband power IC output 9. The resistance and the voltage all we have been marked in this picture. And when you testing all the pins, have one is abnormal, so you just focus on that line is okay. And all the resistance and voltage is normally, and then we need to do next step. We need to test the S2, S3, S4, and S5. All the power is normally or not. And then we need to change the baseband power IC. Still no work, we need to check the main power IC, check the PMU. Okay, now we're talking about the baseband CPU, how to test and repair. First, we need to test whether the baseband power IC, the power supply is normal. And the second, we need to test the baseband CPU is loose or locked. And number 3, we need to check if the communication line with the CPU is normally or not. And number 4 is we need to check the communication with the baseband power IC to check those communication line is okay or not. And the end is check the RFFE bus. And now we're talking about the IF progressor, how to test and repair. First, we need to test the power supply of the RF progressor. And the second, we need to check if the RF progressor is loose or not. And number 3, maybe we need to change the new RF progressor. And number 4 is check if the line with the baseband CPU is normally or not. Those is the RF progressor repair ways. And we need to prepare the local operator band, the distribution table. And as you can see, this is 3 operation band in China. One is China Mobile, and the second is China Unicom, and the number 3 is China Telecom. And you can see all the band and frequency we have been marked down it. And you need to follow it and depend on it to making a table about your country, the local operator, the band and frequency. After you making this table, and you can follow it to repair the signal problem. And in the repair the signal part, in principle, we need to repair the 2G first and then repair the 3G and 4G. and repair the receiving lines first and then repair the transmitting lines. Okay, now we're showing some case to let you understand it more. This is the iPhone 8 heavy file case, no baseband. They are generally have two reasons for the fail of the mobile phone. First is the mobile phone is accidentally dropped and damaged, and the second is the mobile phone accidentally damaged by water. Whatever case there any kinds of the fail, the first step we need to check the motherboard first, rather than repairing it all at once. The solution is take out the motherboard for the checking, and we find that the RF progressor IC is correct. Remove the damaged IC and then replace a new RF IC. Install and test. This phone is become to normal. Okay, switching to next case. This is iPhone 8 jump car. Promote no SIM card after 3 seconds. The SIM card jumping is generally caused by the disconnection or short circuit in the RFV bus of the baseband CPU. The solution is due to the design of the iPhone 8 motherboard. This IC is in the upper right corner of the back. If the phone is loose or disconnect after the phone dropped, we directly remove the DSM HP, the high band antenna switch, and found that the pin 26 and 27, 28 have been dropped, have been missing. And according to the certificate, we can see that the 26 this pin, which is the 1.8 voltage power supply for the high band antenna switch, and the 27 this pin, which is the clock line in the RFFE2 bus issued by the baseband CPU, and the 28 this line, which is the data line in the RFFE2 bus issued by the baseband CPU. The RFFE2 bus disconnection will cause the high band antenna switch cannot be detected when the baseband start to work. So that will cause the baseband CPU will start repeatedly to check this component. So about 3 seconds, indicating that there are no SIM card or searching. So we just make the jumper in the missing point and handle it, replace the high band antenna switch, install and test the phone. This problem is finished. And see the next case. This is the iPhone 8 high fail and case the 3-second jump card is same. After the last case, we will know that the SIM card jumping generally caused by the disconnection or short current in the RFFE bus of the baseband CPU. And we also know that this problem is very easily caused by the right upper corner of the motherboard because the design of the iPhone 8 motherboard. So we correctly remove the DSM-LBE, the low band antenna switch, and found out the pin 7, pin 8, pin 13 have been dropped, have been missing. According to certificate, we can find out that the pin 7, which is the RFFE2 SDATA bus issued by the baseband CPU, and the pin 8, which is the RFFE2, the S clock bus issued by the baseband CPU, and the 13 this circuit, which is the input terminal for the receiving low frequency signal. And this RFFE2 bus disconnection will cause the high band antenna switcher cannot be detected. So the baseband CPU start to work and it will restart repeatedly to check this component. So the phone is in about 3 seconds, indicating that there is no SIM card or searching. So we make a jumper in the missing point and handle it. After that, we install back the IC and install and test the phone. The problem is finished. Okay, so in the next case, this is the iPhone 8 heavy fail and case no service. After the phone have been dropped, it case no signal in the mobile phone, no matter have been installed the SIM card or not, and the baseband was normally. If all the SIM cards have no signal, you need to thinking about the common circuit of the signal. And as we know that the RF progressor is dropped, the phone is easy to be loose. So we replace the RF progressor first and try to repair it. After we replace the new RF progressor, install and test the phone, this problem is finished. So according to this case, we will know that a lot of the no CV or signal problem all is caused by the RF progressor or the low band IC, high band IC, middle band IC, those signal components. Most of them always have been dropped down the phone or water damage. So we just get the phone, no survey and signal problem. We just focus on the signal component part is okay.
结尾，3、2、1，开始。
Hello everyone, this is all the information in this video class. I suggest you guys see this video one more time and make more notes, and when you study hard you will get more. Okay, we can come back to our Facebook group, and if you in this class have some question you can ask and we will give you the answer. Also you have some problem when you meeting in the repair, you also ask. We also can give you the answer for free. Okay, thank you so much.